So here we have a vector question that we want to apply to geometry. We have a triangle XYZ. It has an area of 40 square units, and you're told angle XYZ is acute. You're given some vectors, 6, 2, PQ, and 8 root 5, and you want to find the possible values. Note values, that kind of gives a little bit of a hint. You want to find the possible values of P and Q. And so that then means you probably have more than one value. And your diagram may or may not hint at that when you draw one out. So let's draw a diagram to help us figure out what's going on. So you have a triangle, you know its area. You've got triangle XYZ, area equals 40. Angle XYZ is acute. Now we know YX, and remember it's a vector, so the direction is important, is 6, 2. YZ is PQ, and the length of YZ is H root 5. Okay, so you have some X, you have some Y somewhere. Now from Y to, I'll put Y in the middle. From Y to X is 6, 2. So X is somewhere here. So that's 6 and that's 2. And you're going to have YX. Now YZ is PQ, but we don't really know where that is at all. But we do know the length is H root 5. So H root 5 is about 17. All right, so we've got, okay, so not to scale, maybe I'll make this a little bit smaller to try and make it a little bit better to scale. Oops, that is not the intention at all. Something like that. All right, so you got 6, 2. Now, we have no idea where YZ is, but what we do know, to give you some idea, is that we know its length. So YZ, to give you some broad idea, is going to just go around, not to scale, but it could go in any direction, wherever Z is. So it could go like this, it could go like this, we don't know. And assuming, I mean, this was not a very well-drawn diagram, but basically Z could be anywhere on this circle, in a sense, as long as, if you forgive the not to scale diagram, as long as it's H root 5 in some direction from Y, because we know the length is H root 5, then it doesn't matter. And so whatever it is, it's P across and Q up. Now, wherever Z is, what we do know as well, the third thing we know is P, we know that area equals 40. So there's all sorts of possibilities for where Z could be, and we now need to consider this area. Okay. All right. So because we know the length is 8 root 5 and we know it's P across and Q up, then basically first relationship we know is the square root of P squared plus Q squared is H root 5. Or alternatively, we know that P squared plus Q squared must equal 320. Relationship on number 1. Now, xy is some vector, yz is some vector. You now want to find the area of a triangle. Well, the area of a triangle, note, is 40. And you can think of it as half AB sine theta, right? If you can work out the angle between these two vectors, then you've got half times A times B representing the length of these, times the sine of that angle, and you'll get the area of the triangle. Now, we know the length of YZ because we worked that out, that it was given us. We can work out the length of XY. So let's work that out, right? The length of XY is, well, just the square root of 6 squared plus 2 squared. So really, it's the square root of 40. So it's 2 root 10. So at this point in time, we've got the length of this. We've got the length of this. We now just need to work out the angle. Okay, but that's not too hard either, because you might remember that there's a relationship between the dot products. If you've got a vector A and a vector B, then that is equivalent to A, B cos theta. So that therefore means that if we try to work out cos theta, that'll be A dot B over A, length of A times length of B. And of course, in this context, that's going to be XY and XZ. So we know that, okay, I guess we don't know, which is slightly part of the problem, but that means we've got 62 dot PQ all over square root of 40, which is 2 root 10, times 8 root 5 equals cosine theta. And so if you do the dot product on the top, you've got 2p, 6p plus 2q, over 16 times 5, because root 10 times root 5 is root 50, which is 5 root 2, equals cosine of theta. Now, x, you've got yx, you've got yz, you've got theta. So at this point in time, we've got 6p plus 2q equals 80 root 2 cos theta. And we want to use the area of the triangle equals to 40. So we've got half AB cosine theta equals 40. So I guess we know that that's going to cancel. That's 40 root 2 sine theta. Okay, so we know 40. So basically, we know half AB sine theta equals 40. We know those values. That cancels, so that gives you 40 root 2 sine theta equals 40. So very clearly, we get sine theta is 1 over root 2. So that doesn't mean theta is acute, but it does mean theta must be, I guess, 45 degrees, or, well, 145 degrees. So it could be this, or it could also be like this. Those are your options. But luckily for us, that means 6p plus 2q could either equal two options. Cosine theta is either going to be positive 1 over root 2 or negative 1 over root 2, which means this will either be 80 or negative 80. Those are your two options, right? If it's 1 over root 2 when theta is 45, then it's 80. If it's 3 pi over 4, then cosine is negative 1 over root 2, so it's negative 80. So we have our equations now. Your equations are p squared plus q squared equals 320, paired with 6p plus 2q equals 80, or negative 80. So p squared plus q squared equals 80, paired up with 6p plus 2q equals 80. Interestingly, they're both 80. We'll just double check that. That's 80, and this is also the 320. There we go. Transcription errors are annoying. And we can, of course, simplify this one to 3p plus q equals 40. That's equation set 1. Equation set 2 is p squared plus q squared equals 320. And then, of course, we're left with the negative version, so 3p plus q equals negative 40. And from here, it's really just solving simultaneous equations and quadratics. So let's say we want to solve for p first, perhaps. So we will get q must equal 40 minus 3p. So we've got p squared plus 40 minus 3p all squared equals 320. And a little bit of algebra work. So hopefully we can factorize this. 16 and 8 look appropriate. Okay. So the left-hand side gives you two answers. One is p is 16 and one is 8. So we have p equals 16 or p equals 8. Now, of course, if p is 16, then just subbing quickly into here above, then q is negative 8. If p is 8, then that means q is 16. Let's now solve this side. So we've got, I guess, q must equal negative 40 minus 3p. So you're left with p squared plus negative 40 plus 3p all squared equals 320. So the negative just cancels. So that's plus 1600 plus, well, 240p plus 9p squared equals 320, meaning 10p squared plus 240p plus 1. 280 equals 0. So p squared plus 24p plus 128 equals 0. So this time we want two numbers to add to that. I guess that's plus 8 and plus 16 this time. So that means, I guess, p equals negative 8 or p equals negative 16. And of course, this time we'd be subbing into here to get our q's. So q must equal negative 40 plus 24. That's going to be negative 16. And q must equal negative 40 plus 48. So that means that's 8, giving us 4 possibilities. So we've got 16, negative 8, 8, 16, negative 8, negative 16, negative 16, and 8. Those appear to be all of our values. And now keep in mind what we said with our diagram, right? You've got y. Now you've got x is somewhere here. And so let's just try and draw it out. Now we actually already said there's a theta. That theta is either 45, and that 45 can go both ways, right? You can either have 45 like this, or you could go 45 like this, right? So we'll call this Z1, we'll call this Z2. But so this is a 45, these are your 45-degree angles. But you could also have 135, as we said. So I'm just eyeballing it a bit, but 135 would be like around here and around here. So those would be your 135-degree triangles. So you've got basically 4 different possible triangles, right? So in terms of looking at it in terms of the red and blue one, or you can think of it in terms of the yellow and green one. All of these look reasonably like 40, 40 roughly. They all have, or they all share this one. They all share a length which is approximately what, 8√5 that I'm trying to eyeball, but kind of they all lie on the circle that I was roughly trying to give you an idea about. Obviously, this is not a perfect circle, just to give you the idea. So there are 4 points on the circle. This was 45 and 45 degrees, as we worked out. This was 135, 135, giving us these 4 possible triangles. Now, X was 6, 2. Now, you could have had 16, -8. 16, -8 looks like Z2. So this means you've got the P equals 16, Q equals -8 version. You've got the 8, 16 version. So that kind of looks like this one. Not done to scale, so I haven't drawn it properly. So 8, 16 should have been more up here, but that, in terms of representation, this is the P equals 8, Q equals 16 version. You've got P equals -8, Q equals -16. So, okay, -8, -16. So this is the P equals -8, Q equals -16 version. And you've got the P equals -16 and Q equals Q equals +8 version over here. And that is why you have those 4 different possibilities. And hopefully with this diagram now out, you can kind of see why you have those different possibilities. Each triangle has a roughly equivalent area. I mean, if you drew the diagram properly, they will have the same area. And all 4 points lie equidistant from Y at a distance of 8√5, giving you the area, like fulfilling all the conditions that the question wants. And that's how you do the question.